Welcome. In this video, I will explain 4 separate automated circuits that all employ the use of a photosensor. This photosensor will be used to detect light and determine whether or not an LED is on or off. These 4 circuits all have separate working principles and different components, which I will explain and describe how they're functioning. Circuit number 1, the circuit that's connected in series, was the simplest to build as all the components are connected in series. From the positive terminal, we go through our resistor, our photoresistor, and ultimately to our LED with our cathode connected towards the positive end up here, which is also connected to ground on the anode side. Though it was the simplest circuit to connect, it is the least effective for the results we're looking for in this experiment. For circuit number 2, we use the partial series and partial parallel circuit. From our positive terminal to our resistor, we follow a series path, but once we get to our photoresistor and our LED, it splits off and they're connected in the same line right here, which means they're connected in parallel. The third circuit, the one that uses the transistor, was my favorite to build. For this circuit, we have our positive terminal coming over here to our 100 kilo ohm resistor, which then goes to our photosensor, which as you can see when it covers, turns the light on. This is because when it is light out, as I have this light on right now, the value going from this yellow cable to the second leg of our transistor is an extremely low current, which is almost negligible, which leaves the LED off. When it's covered though, most of the current is running this way rather than this way through the second leg, which results in the first and third leg experiencing the most current, thus turning the LED on. For the last circuit, the circuit that uses the microcontroller, there are basically 2 parts to it. The first part goes through a series connection with the photocell, this pin going to A0, the 5K resistor, which is connected to ground. And then also in series, but in parallel with that section of the circuit, is pin number 8, our LED, with the positive end or the longer leg facing this way towards the top, and this 330 ohm resistor connected to ground. The Arduino was programmed with a threshold value, and with this light shining on it, it is above the threshold value, so the light is off. But once I turn the light off, our LED turns on. The extra step of programming the Arduino ended up being worth it, as circuit number 4 ended up being the most effective and provided for the best results of all the circuits. Thank you for watching, and I hope you enjoyed.